Good morning, everyone. Today we're going to continue our lecture. Last week we have looked on modeling single neuron. Now we look at the many neuron. Okay, let's look on the next slide. All right, today we're going to talk about adding more neuron. Uh, last week one neuron, single one. Now we're going to look at the more neurons. And when we got more than one neuron, two or three neuron, then we're gonna adding more layers. And on layers we're gonna learn about weight, bias, activation function, feed forward, back propagation, loss optimizer, epoch, and learning rate. And hopefully next we're gonna look at this some tutorial. Okay, so these things are basically we are modeling the neuron of the brain into computational model so that the computational model can solve the problem just like how neuron did on the brain to solving a problem. And this is a more important topic, and for your information, these are basically what we call in computer science deep learning, or in other words we say it neural network. Okay, let's go to adding more neuron. Okay, let's see, we're gonna have input 1 and input 2. So this is adding more neuron, more than one neuron. Okay, so this is input, we got to input. Then let's look, we're gonna put two neuron there. So we're gonna adding uh, more than, we're gonna put more than one neuron. We have here two neuron. And so let's look. So in this neuron, basically what you're gonna have is summation product and a function f. So S1 is considered summation product, f is a function, the same thing. So S1 is for this node and S2 for this node. And the f function for both are the same. Okay, so this is where you got two neuron. So each neuron basically gonna have one bias. So this is what we call bias. Okay, so the rule is B1 and B2 are bias. B1 and B2 are bias. Each node has one bias. So this is the rule. So each node gonna have one bias. So this is the second node have another bias. So we got two bias there. Okay, for two neuron has two bias because each node must have one bias. Okay, let's move. So each node has one function fs. So this is function activation function f, and both are the same function. Okay, f this one and function this one are both are the same, shared by two nodes, and bias, and this bias are two different value, b1 and b2. Okay, let's look move. And every input has path to neuron. So this is two inputs, so every input has path to neuron. So this input has path one here and one here. So this input has path one to here and one to here. So we got 1 2 3 4, 2 times 2, so we got four paths. Okay, now let's look the next. So every path has weight. Okay, every part has weight. You need to put weight on every part. So you got four paths, you got four weights. So W is the weight, pemberat. You got weights, something. When you got different value of weight, mean different. Okay, weight is pemberat. Make it different. So the value of weights W1, W2, W3, and W4 are different. So this is called weight. And the most important is every input must have path, and every path has weight. So you got four weights. So let's look. So this is the function of f just now. So every node has one function fs. So these both are the same and share together. Okay, and let's look on the formula summation product here. So you got SW multiplied by x and plus b. So how do we apply this to these nodes? Uh, Last week we have seen one nodes. Now we got see two nodes here, or two neuron. You can see a neuron here. Now let's look. Okay, for S1 here. Okay, for S1 here, basically this one is S1. Okay, and so the S1, the value of S1 basically W1 multiplied by X1 plus W3 multiplied by X2. So you see two output there, two output from different input. Okay, so this W1, remember this, this, okay, and at one this, okay, all right, and another one basically W3 and X2 are multiplied together. So that's what we call summation product. Okay, so these two are combined together to form S1, and S1 plus B, the bias, you got S1. Okay, so you got S1. Then what happening to F? Then simply this S1 basically put in the function F, then you got output. So the S1 will be put S. Okay, S1 is supposed to be here. So the value S1 will be here. So whatever the output is, output 1. Okay, so it apply the same to the second node. Okay, apply the same like this, the above one. Now if the second one basically okay, now you got for S2. Okay, S2. Now you got basically x1 and W1, you multiply, and then this and this x2 and W4, you multiply, and then you add up. Add up, and plus B will equal to S2. Then similarly, S2 will gonna be put in this function, the same function, and you got the output. Okay, I think it's quite pretty clear for two nodes. Last week we have seen one node in quite simple, and this is two nodes. Okay, let's see what's gonna be the next slide. Okay, how do you gonna put another nodes there? I put another three nodes there. Adding. So in this case, adding more layer. Okay, adding more layer. So this is adding neuron, 1 become 2. I adding more neuron, 3 more, but now I got more layer. This is layer 1 and this is layer 2. You got 2 layer. Okay, imitate like a brain neuron. Okay, so how does it work here? So remember, every input must have part to neuron. So every must have parts to neuron. So that's mean no, first before we go to weight, we go to bias. So every node has bias. So this node S3 is bias B3, this is bias B4, and this has bias B5. So the value is different to all of them. Okay, and the function F still the same like this. Okay, all of the same. So now every neuron, every input must have path to neuron. So this is become input to here. So you see you got 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. You got 6 paths. This is 2, this is 3, 2 times 3, 6. So you got 6 path, because every input must has what, 2 neurons. So this is become input to this. So in the same time, you're going to have 6 weight. 1, 2, 3, 4, 5, 6. You got 6 weight. Each weight will be corresponding to one path. And basically the name W5 is continuing with W4 because the value of each weight are different. Alright, so how do you calculate this? The same like this. Okay, now you have S3. S3 basically S3, this one. So you got W5 and output 1 plus W6 and output 2 here. Okay, and lastly you got, no, that's it. Okay, only 2. So plus B3, you got output 3. And the same thing for the S4. S4, then you're gonna have S4. This is S4. Okay, so you're gonna have W7 multiplied by output 1 and W8 multiplied by output 2. Okay, now you sum together and you plus B, you got output 4. So this is output 4. This is output 3. Okay, and the same thing S5. S5 you're gonna have W9. W9 is this. So I've got to note 9 multiplied by output 1. And another one is W10 multiplied by output 2. And you got plus B5. Okay, here B5. Okay, B5. So here you got B5. Yes, that is B5. Okay, B5. Okay, B5. So B5. Okay, just hold on. Just hold on. So this is gonna be B5. Okay, sorry. All right, now we let continue. Okay, so what you got there? Okay, so the same thing. Output S5, basically you got W9. You got W9. This one S5. S5. You got W9 plus output 1. Okay, and W10 plus output multiplied by output 2. And then sum up together and plus B5. So you got output 5. So this is output 5. Okay, so that's the way how you're gonna add more neuron and more layer. So more neuron, basically I got more than one. 1, 2, 3, 4, 5. I got 5 neurons here. And I got more layer. This is layer 1 and this is layer 2. Okay, this is hidden layer 2. This is hidden layer 1. We call it hidden layer. All right, now let's look what's happening next. And for this next thing, you're gonna, so it's the same thing. Okay, you're gonna have the same like this. So this is 10. So you got weight 11, 12, 13, 14, and 15, 15, and 16. Okay, so you got how many paths there? 1, 2, 3, 1, 2. So 3 multiplied by 2, 6. You got 6. 1, 2, 3, 4, 5, 6 paths, as well as 1, 2, 3, 4, 5, 6 weights. Okay, so you got 6 weight. Okay, And so you see there the value, the weight 1, weight 2, weight 3 up to weight 16 all different value. And bias 1, bias 2, bias 3, bias 4, bias 5, you got 5 different bias. So this is considered the output, okay? Output layer. Why I said output layer? Simply because I got the target value 1, target value 2. Remember target value last time? So when we get target value, this is considered the output layer, okay? Output layer. So output layer doesn't have bias. Remember that. Output layer doesn't have bias. Okay, it's just empty. So basically you're gonna don't have this. So W11 multiplied by B3 sum with W3 multiplied by output 3 and so on. You can count yourself just similar like this. But this time here we don't have bias. Okay, we don't have bias. All right. So when we have target value here, target value basically you're gonna have loss. Okay, remember the target value gonna minus the output from 3. So the 3 is come here, yeah, and this come here, and then go to F. So whatever you give F here, so the target value 1 will minus F, you'll got loss. So every part has loss. So average the loss. So you have here 1, and then you got here also. Just hold on, okay. So this is another one. So this is another one. 1, 2, and 3. And 3. Okay, and 3. So these 3 are simply like this. W12 multiplied by output 3 plus W14 multiplied by output 4 plus W6 multiplied by output 5 plus, then you sum up together, but this time no plus B, P5, no. So you got loss 1 here, loss here, target value minus F, target value minus F, and here also you got loss, okay. So target value 2 minus F, target got loss here, target value 1 minus F, okay. So you got loss here. So just take two loss, sum up together and get the average. So that's what you're gonna have a loss. Okay, now loss is the average of both loss. Now this is what we call feed forward. Okay, feed forward mean from the x1, from the x1, from the x1, the input are moving this way to the right, are moving to the direction to final Fs. Okay, Fs. And weight and bias are assigned. So you have weight are assigned. So assigned mean you got a weight and its value. Okay. And bias B1, B2, B3, B4, B5. And loss is calculated. Here you got loss here, you got loss here, you got average of the loss. Sum up divided by 2. So you got average of loss. Once you got the loss, it is a feed forward. This is what you call feed forward. So you're gonna feed it from the beginning toward the end. So you're moving forward. Okay. So that's the term moving forward. All right. Let's look on the next slide. Okay. So now we are feed forward, isn't it? Okay. Now you have to move backward. Okay. You have after you got the loss, you need to move backward. So move backward, what we call back propagation. This one it. When he moving back, it is called back propagation. And what happened in back propagation basically, we go backward in effort to change value W and bias. So while we're moving here, we're going to change this value. We're going to change this value to certain number. Okay. If previously was 1, now when we change become 0 or 2 or become 3, we change the value of weight and bias. Okay, we change the value. So when we moving backward, we change the value. Okay, and optimizer function, there is a term called optimizer. So this function, if you run it, they're gonna change this W. Okay, I said we're gonna change the value of weight bias. That's I said, but we need some doer. Kena buat. So this optimizer, when you run this, it changes the value and the bias. Okay. Okay. The one I said is changed, but you need some function to do that. Okay. You need somebody to do it. So optimizer is someone or function that do the change value and bias. So we need to call this to change the value of weight and bias during backward or back propagation. Okay. Moving backward. When we say back propagation, mean it related to optimizer, and optimizer will change this value. And when you change this value, basically you have this another term, learning rate. It is a set the rate of change. Now we have initial value before at the beginning. Now when we moving backward, we're gonna change this one. How rate is the change? If let's say this is 10 at the beginning, now we want to change to what? 8, 9. So if this is 10 previously, I change to 9. So the rate is bit lower. The rate is lower. 8, 10 become 9. If the rate is bigger, from 10 to 2, that's the rate is become bigger. They change from 10 to 2. So the learning rate is bigger, means that if initial value W is 10, it's going to change to 2 because the learning rate is bigger. If learning rate is smaller, from 10 to 9. So we have to running this function as well. So both optimizer function and learning rate function, they're gonna run together. This gonna change the value, and learning rate is how much rate that you're gonna change, big or small. So the gradually become smaller, how big is the gap between the change. Okay, that's a back propagation. So remember the word back propagation. Okay, back propagation is moving backward to change the value W and bias, and the change can be done by calling this function optimizer. Okay, in computer science we just call a function. When we click the icon of our handphone, when we click, that means we click that function. Okay, this function named optimizer. So WhatsApp, the function of WhatsApp, you just press the WhatsApp, you're gonna execute. So the same thing, optimizer. Then when you call optimizer, learning rate will be all put together. All right, so next slide. And now you got, at the beginning you got feed forward, and here you got loss. Okay, then you moving backward to do the propagation. Here change the weight W and bias gonna be changed using the function optimizer along with the learning rate. Then this one and moving back again, this is called one epoch. Okay, so if you move one and then you moving backwards, this is called one epoch. Okay, one epoch consists of one forward direction and one backward direction, the red color, and optimizer execute. Optimizer function are being calling and learning rate for all the input data. Okay, so you're gonna do X1. and this is called epoch. Remember the term epoch, okay? So then what happened? Then remember, you have to move, then you have to move again forward. Repeat, okay? I mean, you're gonna repeat back again. So in this case, now you got a new value, weight and bias. Remember, they during back propagation, they changed the value and weight and bias using optimizer and learning rate. So we got a new value of weight and bias. So you're gonna do the same thing, okay? You got how many weight? 1, 2, 3, 4 with the new value. Then you're gonna apply x1 multiply w1 and x2 multiplied by w4, and you sum up, you do the function and so on, all those things until to the end, okay, until another loss you target value. Then this is you have make from x forward direction to fs, weight and bias assigned and calculated. The same thing, you repeat the thing again from the beginning, and then you going back. So now is second epoch, okay? Just now the first epoch, now is second epoch. So it goes here like this, back and forth. How many times? It's up to you. It's up to you how many times you want to set moving forward and moving backward, okay, to do the propagation. So how many move forward and moving backward is up to the designer. We are the design. It's up to me to set how many should be forward and backward, and up to me how many node I want to put and how many layer I want to put. Is up to me, okay? So basically, remember last week, the target loss will be 0, okay? So you need to go for moving forward, backward, moving forward, moving backward, move forward, backward, one epoch, second epoch, third epoch, fourth epoch, fifth, 7, 8. See the loss, not 0. Okay, you go again. 8, 9, 10, 11, 12. Look the epoch. Okay, not yet loss. Not yet the loss becomes 0. Almost. Put another 3. Then suddenly loss becomes 0. Then you stop. Okay. So when loss is equal to 0, you can stop the epoch. And basically, epoch, let's say you can have like this, you know, epoch and iteration. Epochs, iteration mean how many times you iterate, you repeat the moving forward and backward. So let's say the epochs we set is 40, and we got 100 input. Sample is input. Okay, we got 100 input, and we set epoch is 40. So we're gonna get this 100 input 40 times moving forward and backward. Okay, 100 times. So less or than equal to epoch. So means that for I is normally assigned to 1. So 1 to 40, okay, equal to 40. So compute loss and optimize. So you do it until 40. So this in computer science we call it loop. We set f 40. Okay. So in this case, let's say I is equal to 1. Okay. Now this is in computer science. Okay. This is what we call pseudocode programming part. Just let's say I is equal to 1 and epoch I set 40. I can set 50, 60. So for I less than or equal to epoch, which is 40, compute loss and optimize. In other words, moving forward and moving backward, moving forward, moving backward. So now I is equal to 1. Compute forward and backward, loss is got, plus 1. Now I become 2. I now 2 less or equal to 40, still valid, so it go until I is 40, less or equal 40, yes. If I is 41, is not less, is more, or not equal, is more than epoch, so it stop. So it's just to say that we're going to have 40 loops moving forward and backward. So then this will be transformed into programming language. Programming language will follow this one. All right, I think that's epochs and iteration. Let's see on the next slide, hyperparameter and hyperparameter. Okay, that's the definition of hyperparameter and the definition between uh, parameter and hyperparameter. Okay, so parameter, what does it mean? Any value that changed by computer, such as weight and biases. So this value, weight and bias, normally when we call optimizer function with learning rate, the computer will automatically update or measure. We don't update it because we're gonna dealing million of that weight and bias. Okay, and so this is update by optimizer, means that computer do it automatically. And hyperparameter mean any value that changed by human. What did you change? The learning rate. We're gonna set it high or low, depend on me. Epoch, depend on me. I can set it 40, 50 or 60 or even 100 or million. Batch. Batch is simply if you got 100 input divided by 2 batch. Okay, you're gonna run it batch by batch. Okay, so I set it anytime I want. One batch is 20. If I got 40, I got 2 batch. Number of layer. Okay, so it's up to me. I'm gonna put 10 layers, and each layer is gonna have how many nodes? Up to me. I'm gonna set it 100 nodes or probably million nodes, and so on. Okay, and drop out rate and so on. Okay, this you don't have arrived in this drop. Forget about the drop term. Okay, but the most important is hyperparameter. Basically, it is a variable that we human change it, whereas the term parameter is any variable that, such as weight and bias, which changes the computer. Okay, we got a function optimizer, they're gonna change itself. He do the change, we don't worry about that. Okay, all right, now tutorial a bit. Okay, how many parameters in this model? Okay, so here I got two, I got four here. 2 plus 2 is 4. 4 plus bias, num. Okay, 4, 5, 6. So here, okay, and then we got 1, 2, 3, 4 bias parameter. Then I got 10. Then I got 16. So in this case, I got 16 weights. And how many bias? 5. 1, 2, 3, 4, 5. So 16 plus 5 mean 21. So I got 21 parameter. Okay, 21 parameter. Okay, in this case, weight and bias is parameter. I got 21 parameter because I got 16 weight plus 5 bias. 16 plus 5 become 21 parameter. Okay, 21 parameter. And how many hyperparameter? This F1, number of node, number of layer, how many nodes, and so on. That's becoming hyperparameter. Okay, now in this case, how many layers? So in this case, this is the input. So layer hidden layer 1, hidden layer 2, hidden layer 3. So you got how many layers? You got 3 hidden layers. How many nodes you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, 12, 13 plus this one. Okay, so I got 13 nodes there. How many input? I got 4. Okay, how many activation function? So every node here has activation function, all the same. So I got only one type of function get used by all nodes. So in this case, I got how many nodes? I got 13. So you got 13 activation function, but these 13 are almost the same function. So one type, okay? Whereas the nodes here, 13, okay? How many classes? Classes mean how many target. So I got 2 target. This target value. So I got 2. So how many weights? How many weights? 1, 2, 3, 4, 5, 6, 7, 8. No. How many weights? So basically, okay, this is for, you got 16 here, isn't it? So here you got 4, you got 3, 12 here. So you got 3 and 4, 12 here. You got 4 to 2, you got 8. Then you plus all together. Okay. So how many? 48. Okay, I got 48 weights. So how many bias? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because every node has one bias. Every path has weight. So this is 16 simply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, you got 16 there, and then the rest is the same. Okay, so how many optimizer? Only one optimizer. That optimizer, when you moving backward, you're gonna change all the weight and bias. How many parameter? 48 plus 2, 50. 50 parameter. Okay, so weight and bias. Weight 48, bias 11. No, 48 plus 11. So that's mean, hold on. So this is not 50. Okay, so this is basically 48. How many parameter? So 40 weight and bias. So 50. Optimizer only one. We're going to use one optimizer for whole epoch. Okay, got it? Okay, now let's move. Design the neural network of the following setting. So how are you going to design it? Okay, so you got two input, x1 and x2. Layer 1 for node 1, 2, 3, 4. Layer 2 3 node 1, 2, 3. Layer 3 8 nodes 1, 2, 3, 4, 4, 4, 5, 6, 7, 8, 9, 8 only. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I got 8. Two output as a target value. 1, 2. Okay, that's it. That's it? No, not yet. So I'm gonna have how many? So basically later on, I'm gonna have 2, 1, 2, 3, 4. 4 times 2. You got 8 bias. Before that, okay, this is gonna be there. Then design the network. So After you draw this, what function, activation function you're gonna use? Softmax, and very many various, you can pick one. And optimizer function, what is it? Learning rate optimizer, and then the learning rate. Okay, learning rate. So basically, when we set design, you have to design this according to this. You got this, and you will have to activation function, here. Okay, so what activation function you're going to choose, what optimizer you're going to choose, what learning rate choose. So basically these are decided by me or by you. Okay, how many input, how many layer, how many nodes, how many output, and what function to have. And after you got this, you just run. Okay, run the program, and you got it. At the end of the day, how the target is, loss is 0. Okay, so thank you. I think we'll continue again for the next lecture, and we're gonna discuss it later on. Okay, thank you very much.